part 3 with chemical reactions. Left off balancing these equations and looking at them. And as we look off in this first example, I won't go through every one. I'll just go through one or two, and then you can do some examples on your own. But I would start with 1 silver on the left side, and I'd look on the right side without me putting that 2 in there, which wouldn't have been there to start with. I have 1 on this side. So I wouldn't do anything yet. I would just say, okay, now I'm going to go over to the nitrates, which I said last one, keep that together. I have 2 nitrates on this side, NO3s. I have 1 NO3 on this side. That's why I would put this 2 up in front. Once you make a change to the coefficient, like I had to there, then go back and look at whatever you did first. So I would go look at silver next. And then I'd say, oh, I have 2 silvers now. What do you have to do to this side to make it 2? Put a 2 in front. So by satisfying the law of conservation of mass for nitrate over here by putting a 2 over here, I then had to put a 2 on this side. Once that is, I go back and double check. 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 1 copper, 1 copper. So I don't have to put a number in front. Remember, if there is nothing, just like if there was only 1 element, I don't have to put a 1 down as a subscript. I don't have to put a 1 as a coefficient if there is no more than just that. So then this would become balanced. If I look at this one down here, we'll skip down to phosphorus. Again, I would start with 1. I would look to this side, it automatically has 4. Hence, I'd put the 4 in front of the phosphorus. I'd look at the oxygen and say, well, I have 2 over here, but you have 10 over here. What times 2, since I can't change this 2, but what times 2 can give me 10? That's where the 5 comes from. So you'd put a 4 and a 5 here, and then I would leave this a 1. And you end up doing that over and over again. It's like a puzzle. It always comes out because in order for this to be an actual chemical reaction, it has to satisfy the law of conservation of mass. If it doesn't, it's not a real chemical reaction. It'll never happen. So there's kind of a brief introduction into balancing equations. Pretty simple. It's tedious. Sometimes you got to go back and forth. They eventually work out. But the last part we get into in this chapter is the 5 major types of reactions. Being able to identify them is really all I'm going to have you do. If you look at this second part, B, it does allow us to predict the products. So you can kind of say, what if I mix this and this together? It will tell you what the products are going to be as long as we know those 5 or 6 major types that we look at. So how do you recognize them? You look at what the reactants are. So combination reaction is the first one. To combine means to put together. So I'm going to just look at the reactants. How many reactants are there? Not number of atoms, but how many compounds or elements. In this case, you have 2 because there's a plus sign in between them. So I have 2 things. How many do I have on the product side? I only have 1. Even though that's a compound, it's combining those together, hence the word combination. But there's only 1 thing on the right side. Look at this second example, sulfite or sulfur trioxide plus water. There's a plus in there, so I have 2 things, and after it's becoming sulfuric acid afterwards. So it's 2 things becoming 1. And you can use it to predict. Obviously, if I'm going to take magnesium and combine it with nitrogen, this is a +2. Nitrogen would normally be a -3. So when you combine those, I still have to make sure my if I say magnesium nitride, it's going to still be that same equation. You can't just put MgN2 because that doesn't satisfy everything. Just know the magnesium and the nitrogen come together. That's why we're not going to do a lot with predicting in this week. Second type is decomposition. It's the opposite. I'm going to start with 1 thing, and it's going to decompose into 2 things. It's going to break apart. So here's another example. Calcium carbonate is going to decompose into calcium oxide plus carbon dioxide. Can put 1 thing into 2 things. In order for that to happen, most of the time, there needs to be some type of energy, and I said we'll put that on top. In order for this reaction to happen, you have to have electricity, you have to have some type of energy or heat, light to go on. The third type is called a single replacement. Now, in this part, I'm going to start with 2 again, and it's going to become 2. So 2 reactants become 2 products. The difference is I'm switching what the combination. There's always a single with a compound. Notice here sodium's a single element with a compound. This is fluorine with a compound. So you're only switching 1 partner. In this case, sodium is switching with potassium. So potassium's all by itself as a single element, and then sodium's with the chlorine. It's a single replacement. Here, fluorine's all by itself, but it can't